Hi, this is the first video on radicals and surds. So a radical is a number that is written using the radical sign. So previously, you may have called this the square root sign or the root sign. It's actually called the radical sign. Radical numbers can be rational or irrational, and an irrational radical we call a surd. So that's one that we can't work out. For example, the square root of 2 is not a nice answer, therefore it's a surd. Whereas the square root of 4 equals 2, so that is not a surd. So the square root is this one here, like I've got here the square root of a, and just some information, is only real if a is greater than or equal to 0. That means we can't square root a negative number. The square root of a times the square root of a just equals a, and the square root of a we can actually also write it as a to the power of a half. So there is this little rule that you can do as well, which is the nth root of a is equal to a to the power of 1 on the little number that's outside the front of the radical sign. If we have a cube root, so it's a little 3 root a, then that one cubed just equals a. In this situation, if a is greater than 0, then the cube root is greater than 0, and if a is less than 0, then the cube root is less than 0. And we can rewrite the cube root of a as a to the power of a third. So we're going to just look at some simplifying radicals. So if you have the square root of a times the square root of b, we can combine that into 1/3, so the square root of a times b. And then if we have the square root of a divided by the square root of b, we can write that as 1/3, big surd, which is the square root of a over b. Just going to look at a fair few examples just so you can see how these work. A, the square root of 5, all squared. So this is obviously the same as the square root of 5 times the square root of 5. If we look at that first simplifying radical rule, that equals the square root of 5 times 5, which is 25. And we know that the square root of 25 is 5. So obviously you don't need to do that working for these generally, but it just shows that what I said earlier up here, if I just scroll back up, I'm just going to put a purple star next to it, how that actually works. And that's shown in this example. Okay, B. We have 1 over the square root of 5 all squared. Remember, when we have as power outside the brackets, everything in the brackets gets that power. So it will be 1 squared over the square root of 5 squared. 1 squared is obviously 1. And in the previous example, we know the square root of 5 squared is just 5. So it'll be 1 over 5. C, 2 root 5 cubed. So everything in the brackets has to be cubed. So we'd have 2 cubed and then root 5 cubed. I'm just going to write this out further. So 2 cubed we know is just 8. Now this would be times by the square root of 5 times the square root of 5 times the square root of 5. Now we know that the square root of 5 times the square root of 5 is just 5. So that will end up being 8 times 5. Then we've still got 1 square root of 5. So our answer will be 40 root 5. And we just leave our answer like that. D, we've got negative 2 root 5 times 3 root 5. So this works the same as like terms. We can multiply things in any order. So we can actually, with this one, we can do negative 2 times by the 3, and then we'll have the square root of 5 times the square root of 5. Because everything's multiplied, we can be done in any order. So negative 2 times 3 will be negative 6. And square root of 5 times square root of 5, once again, is just 5. So this will equal negative 30. E, we have square root of 3 times the square root of 2. So just the rule, if I just go back up here, that's simplifying radicals, that first rule there. This will equal the square root of 3 times 2, which equals the square root of 6. F works similar to D in that we can do the numbers separately. So we'll have 2 times 3, and then the square root of 5 times the square root of 2, which will be 6. Multiply the square root of 5 times 2, which will give us 6 root 10. G, we've got a couple of divisions now. So with G, we can make this a big one, so we can actually have it as the square root of 32 on 2, just as that second rule above shows us. And now 32 divided by 2 is 16. So we'll have the square root of 16, which is just 4. So using these rules can sometimes help us simplify. And then h, same idea. Square root of 12 divided by 2 root 3. Now what I'm going to do here is that divided by 2, I'm just going to make that a half out the front. And then we'll end up with the square root of 12 over the square root of 3, and we can work with that separately. So we'll end up with a half times by the square root of 12 over 3, which is a half times the square root of 4, which is a half times 2, which just equals 1. And then we can actually look at the h a different way as well. So what we can do with h as another option to solve this, let's put a line down here, we could write 2 as a square root. So if we think about this, we could have the square root of 12. Now 2 we could rewrite as the square root of 4. So we would have the square root of 4 times by the square root of 3, which would give us the square root of 12 over square root of 4 times 3, which is the square root of 12 over the square root of 12, which just equals 1. So there's different ways you could approach it. Either way is fine. They both give you the same answer. It's just a personal preference. And that is the end of our first radicals and surds video.